Have you ever found yourself in a situation where you needed to prove who you are? Maybe it was at the airport trying to board a flight to your dream destination. Perhaps it was at the bank hoping to access your hard-earned savings. Or maybe it was something as simple as picking up a package at the post office. In all these scenarios, one thing remains constant: the need for a physical identification card. And how many of you have ever been in a situation like this? You stride out to the DMV, relieved to have replaced your lost ID or driving license, feeling secure once again. However, moments later, you receive an unexpected message. Someone has found your lost ID. Confusion sets in as you realize you've spent hours in queues and paid the replacement fee totally unnecessarily, and you need to visit the DMV again to turn in your old ID if you're a responsible citizen anyway. Happened to me once, not a pleasant experience at all. If only there was a way to avoid situations like this. But I have some good news today. My name is Igor Rosocha, and together with Mykhailo, we'll talk about creating digital identity app for Czech Republic called eDoklady, which will hopefully replace IDs and driving licenses once and for all. I'm going to start with a little introduction of eDoklady mobile app, its base principles, and take a closer look at other countries' solutions. After that, Mykhailo will take over and provide you with an in-depth exploration from a technical standpoint. All right, let's get it started. Let's answer the first question right away. What led the two of us, me and Mykhailo, to talk about eDoklady today? First of all, we at Ackee are responsible for implementation of native core frameworks, both for iOS and Android. Not the app itself, application is managed by the state. Second of all, there has been some skepticism among the public regarding the need and usability of the application. News about the release took storm on social media with questions like, why the hell does the app ask me to turn on the Bluetooth? Or what about security? How could it possibly be secure? Can I trust the app? Or what will happen after the European Digital Identity Wallet will be released? The app will be discontinued and all the money will be wasted, right? So we're here to address these questions. Allow me to introduce the eDoklady mobile app to those of you who maybe doesn't know about it. It allows for identification using a digital copy of an ID during physical inspections. Please note that it is solely for physical inspections and should not be used as an application for accessing online services. Initially, only the national ID card will be supported, with other documents such as driver's licenses, students' IDs, etc. to be added later. Currently, it is accepted by the police, for example, when you get stopped driving your car, and at selected government offices and ministries. And starting from summer 2025, it will be a legal requirement for all government offices, post offices, and banks across Czech Republic. Let's take a closer look at how eDoklady app looks like. There are two base types of flows, and those are proximity flow and remote flow. Important to note here that for both of these flows, the data transferred is the ID representation itself, not just some unrelated token or identification. However, you only share the information which are requested from you. For example, if a bartender asks you to prove you're old enough to have a drink, you only share the proof of age, not your name or other information which the bartender could possibly exploit. So, first of these flows is a proximity flow, and it takes advantage of Bluetooth technologies. As the name suggests, proximity flow is based on close proximity of devices. And we know two types of these devices. The first one is the device of citizen with the app representing his ID, and the other one is the verifier or the office who needs to verify citizen's identity. So, let's take a look at how the proximity flow works like in practice. Unfortunately, as this app serves only for Czech citizens, is localized to Czech language, but I'll do my best to explain what's going on in the video. You can see the citizen app on the left side and the verifier app on the right side. So in the first step, verifier chooses the information category to verify. Citizen then prepares his personal QR code. Verifier then scans the citizen's QR code, and if a citizen gives the permission to share his data which are requested from him, data is transferred to the Bluetooth, and verifier can see all the required information, just like that. The second of these flows is a remote flow. You'll encounter and use remote flow mainly behind the counters in the offices. The reason for that is that remote flow works only online, not through Bluetooth or some other proximity technology, mainly to save costs of buying new devices to the offices which already have desktop PCs and internet connections which they can take advantage of. So, Right here, we can see the remote flow. The application on the right side won't be visible to the citizen, as this will be run on the device or a computer of the verifier behind the counter. So in the first step, the verifier chooses the information category to verify, which will create a unique QR code. Then the citizen scans the QR code behind the counter, and if citizen gives a permission to share his data, the data is transferred remotely, and verifier can see all the required information and can verify the citizen. Marvelous. So now we know how eDoklady works and how it looks like. But let's take a closer look at solutions of other countries. Well, the first country in Europe to introduce a digital driver's license on mobile was Iceland in 2020. Excuse me, I do not dare to pronounce its name. It can be used as an official alternative to an identity card, but it only works within Iceland's territory. It operates on the passbook principle in Apple Wallet, and as you can see, the document contains a unique barcode that is periodically refreshed and serves for authentication purposes. So in the same year, Denmark also introduced applications for driver's licenses. Similar to the Icelandic solution, this application is considered as an official alternative to an identity card. And different from the Icelandic solution, authentication operates on the principle of a rotating QR code. And this QR code, which you can see right here, it contains a photo and a document identifier. And then the third one, the well-known Ukrainian application called DIIA. It supports a large number of various documents. It is possible to scan a QR code or a barcode. Both of these are supported, and both of these contain a unique token. And if we take a look at the entire European Union, there's currently 6 states that have implemented MDL. By the MDL, I mean the mobile driving license, not some standard. And these are Denmark, Germany, Spain, Greece, Poland, and Portugal. So right now, can you guess what these MDLs have in common, being the main downside of these implementations? Maybe some of you would guess correctly that they are all based on their custom implementations. Great. So now we have multiple applications and digital licenses across Europe, which cannot communicate with each other and are not standardized in any way, which basically means your driving license can be used only within the borders of your country. Is this truly the right course of action? Let's take a look at United States of America. You might think that the implementation of various mobile driving licenses applications across Europe, which can communicate with each other, is comparable in complexity to rocket science. However, the USA are a great example that it's really not that impossible. Right here on this image, you can see that 12 states, the purple ones, already use applications, often different ones, but they are all interoperable with a single standard. The purple ones with the dots are already in the process of implementation, such standard, and then you can see the green ones that are working on legislative to make it happen soon too, and to use the single mentioned standard. And that standard is called ISO IEC 18013-5, and that's the very same standard that eDoklady complies with from the beginning. Furthermore, the ISO MDL standard has been developed with the involvement of several major technology companies, including Apple. That means that even the implementation of Apple Wallet ID supports this ISO standard. Therefore, the authentication application for eDoklady should be able to authenticate documents from Apple Wallet in the future. Unfortunately, it's impossible to add check identity card to Apple Wallet right now, and there are basically 2 main reasons for that. The first reason is that the functionality is restricted by Apple solely to American market for now, and the other one is that Czech and European legislation is not prepared yet for that to make it happen. And at the time, in the United States, it's only possible to add 4 of the states' IDs to the Apple Wallet. But don't despair, it seems that brighter times are also on the horizon in the European Union. In the European Parliament, a proposal to revise the directive on driver's licenses is pending. There should be a unification of MDL applications and systems, and they should all be obliged to be interoperable with the mentioned ISO standard. And then there's EUDI, which stands for European Digital Identity. On the GitHub repository for EUDI, you'll find that the remote flow variants are to stand on top of OpenID for verifiable presentations, and proximity flow variants on the mentioned ISO standard. And we are so proud that eDoklady comply with both of these. But enough from my side. I now pass the floor to Mykhailo, who will dive into technical perspective.
Hi, my name is Mykhailo, and now that you know what eDoklady application is about, let's take a look at it from a technical perspective. To give you more context, let's begin by talking about general technical requirements that we had for the app. In other words, what it needed to be able to do. First, we needed to be able to download the document and then to store it securely on user's device. Next, we needed to implement sharing of the document via Bluetooth according to the ISO standard. And lastly, we had to implement a process of sharing documents with remote reader. This had to be done according to OpenID for verifiable presentation standard. As for the architecture of the eDoklady, the mobile applications are written in React Native, but the React Native part mostly has UI, while the business logic is implemented in native modules separately for each platform. The app communicates with two backends in total. The first one is NIA, which stands for National Identity Authority. It is responsible for authentication, and the app communicates with it through a native module called NIA Bridge. The second backend handles all other business logic, such as issuing credentials and others, and the React Native app communicates with it through a eDoklady native module. This is the module that we at Ackee have developed, so today we'll be focusing on it. To start, let's see what specifically our module handles. In short, it has all the business logic that's related to documents. First, it manages the document by downloading it from the backend and storing it in secure storage. Next, it implements the ISO standard for proximity flow and handles all the stages in sharing the document via Bluetooth. And finally, it also manages the whole remote flow. All the React Native app has to do is just call a couple of methods from the module, and that's it. All the logic is handled by the module that we've developed. Now that we know what our module does, let's see which security mechanisms are used there. And we'll start by seeing how we protect users' documents. Well, to do that, we first need to get the document to the user's device. For that, an HTTPS request is used, which is secured by JWT token. This token is signed with a device key, which is generated locally and never leaves the key store or keychain, depending on the OS. As a response, we get a document which contains various security structures from the issuing authority, as well as a public part of the device's key. This ties the document to a specific device, which requested and received it from the backend, because no one else has the key that was generated on device. This is what makes it impossible to copy the document. So how do we then store documents on devices? On Android, we are using Applications Secure folder, and we also utilize additional encryption using a key from KeyStore. On iOS, we use Keychain to store all the sensitive data. And those storages are really, really secure. Just as a fun example, if you take a look at Samsung's hardware security module, in addition to different detectors of unusual temperature and voltage, they literally mention that they have detectors of lasers there. So even if someone with a laser steals your phone, your documents will still be protected and impossible to steal. Now that we have our documents on device, let's see how we are able to share it through proximity flow. As I've already mentioned, the process is implementing a subset of the ISO standard. The standard itself is really big and covers various features. For example, for device-to-device transmission, it supports Bluetooth, NFC, and Wi-Fi aware. For the eDoklady application, Bluetooth was selected as the most appropriate technology, and this is the one that was implemented. And since the document that's being shared is stored locally on the device, and Bluetooth is used for communication, the whole process can also work while user is offline, which is a great benefit. The security mechanisms behind the proximity flow offer protection against various attacks, such as forgery, copying, eavesdropping, and unauthorized access. And this is achieved through 4 different security mechanisms. The first one is session encryption, which protects the communication between the devices from eavesdropping. The second one is issuer authentication. It makes sure that the document comes from a trusted issuing authority and that the items were not modified in any way and are the same as they were issued. It also ensures that the document hasn't expired and is still valid. This is what makes forgery impossible. The next one is mdoc authentication. I've already mentioned it when describing how document is downloaded. The idea is that it ties the instance of the document to the device that received it from the backend. This protects it from copying because even if you copy the document to a second device, it will still be unusable there because that new device does not have the private key of the original device, which is stored in the key store, and it's impossible to get it out of there. And the last security mechanism is mdoc reader authentication. It ensures that the verifier has the authority to perform the check and also makes it possible to show the mdoc the identity of the mdoc reader. Now, let's take a look at the whole process in more detail. On the left, we've got citizen, who will be proving their identity. And on the right, we've got the verifier, who will be checking citizen's identity, like a police officer, for example. We'll be using the terms as they are defined in the ISO standard. So we'll be referring to the citizen as mdoc and to the verifier as mdoc reader. Before starting the process, each party has some prerequisites that they have to do beforehand. For the mdoc, they need to download the document, generate a key pair for session encryption, and download a trusted certificate for verification of mdoc reader certificate. The mdoc reader needs to create certificate for mdoc reader authentication and download a trusted certificate for issuer authentication. When starting, the mdoc reader needs to select which fields from the document they would like to check. After that, the mdoc generates a QR code with a so-called device engagement structure. This structure has all the information necessary to establish a secure Bluetooth connection, such as mdoc's public key for session establishment. The mdoc reader then confirms the items they would like to check and scans the QR code. After that, they handle the device engagement structure, which was encoded in the QR code. While processing the structure, mdoc reader generates a session key pair and establishes a shared key using elliptic curve Diffie-Hellman key exchange. Once the session is established, a symmetrical encryption algorithm is used, namely AES 256, to make the connection secure. Then the device request structure is created on the side of mdoc reader. It contains requests for specific items and also includes a signature and certificate for mdoc reader authentication. After that, the message to be sent is assembled. It includes the device request, which is encrypted with symmetrical session key, as well as mdoc reader's public key for session encryption. This message is sent to the mdoc. mdoc receives it and uses the mdoc reader's public session key to establish the same shared key, again using the elliptic curve Diffie-Hellman key exchange. After that, using the shared key, they're able to decrypt the device request. Then the mdoc needs to check the mdoc reader using mdoc reader authentication. This ensures that the verifier is authorized to perform the check and prevents unknown parties from getting access to the documents. The mdoc then asks the user to confirm if they are OK with sharing the requested items. And once it's confirmed, the mdoc gets the document from secure storage, and then they create a device response structure. This includes mdoc authentication, which is a signature or a MAC of the items in the document. This step is what protects the document from being copied, because the key that's used there is the one I've already mentioned before. It was generated while downloading the document. The device response is then encrypted with session key and sent to the mdoc verifier. The verifier decrypts the response, and then they start the verification process. And first, they need to verify the received data items using the issuer authentication. And this is a very important step in the process, so let's take a look at it in more detail. The mdoc reader here performs a series of checks to make sure that the document is authentic and to prevent possible forgery. This consists of validation of certificate of the issuing authority, validation of the signature of the issuing authority, check of the hashes of the items they received against the hashes of the items which were provided by the issuing authority to make sure that none of them has changed, and validation type of the document, and verification of various dates, such as of the signature of the issuing authority, the start validity of the document, and the expiration date of the document. And as a last step, mdoc reader needs to check the mdoc authentication. And if all validations pass, the data is displayed to the mdoc reader, including the validity of the document. So that was quite tough, right? Well, I promise that the hardest part is already behind us. Now let's switch to the remote flow. The remote flow is based on the OpenID for verifiable presentations standard. It only works online because the document is supposed to be shared via internet. And to start this process, citizen scans a QR code, which is located at the counter of some governmental institution. The communication consists of two requests. When the citizen scans the QR code, an HTTPS request is sent to the URL, which was encoded in the QR code, and as a response, they get a document request. After the citizen confirms that they are OK with sharing the items from the document that were requested, a second HTTPS request is sent with the required data, so the items from citizen's document. Let's now take a look at how this process is secured. First, the contents of the QR codes are validated against a list of trusted readers to prevent sharing the document with unauthorized parties. Both requests use JWT tokens for security, and it relies on the same security mechanisms as proximity flow, such as mdoc authentication, mdoc reader authentication, and issuer authentication. In general, remote flow is based on the ISO standard as well. Now, you might be asking if we faced any major challenges while implementing all of this. And the answer is yes, we definitely did. The biggest issue is that this ISO standard is not widely used yet, so we had to implement custom solutions for almost everything. There were no existing solutions or libraries on iOS which could help us, so we had to do the whole implementation from scratch. As for the Android, we found an unofficial library from Google, which was implementing almost everything that we needed, so we were very excited about it at first. But going deeper into it and trying it out more, we started noticing some problems. For example, the Bluetooth communication would sometimes completely stop working after some documents were already shared. So let's say we shared 5 documents already, and after that, any new attempt to share another document would always fail. So we thought, OK, maybe they'll fix it with some new release. So we checked how often they release updates to the library. And we were very disappointed to see that the last update was released a couple months ago. And as a cherry on top of this, the library is written in Java, making it more tedious to work with it from Kotlin. So the decision was clear. We had to implement it from scratch as well. And this is exactly what we've done, which gave us just amazing control over the whole process, and also ability to test it thoroughly without having to rely on any third parties. And since I've already mentioned testing, I can proudly say that we've achieved 90% test coverage, so the implementation is really very well tested, as it should be for such an important project. And talking about importance, it's time to sum things up. During the first month after release, the eDoklady application was downloaded by 300,000 users. It's implementing an international standard, which makes it possible and relatively easy to integrate it with solutions from other countries in future. And at the same time, it's the first implementation of the standard in the European Union. We hope that it'll change in the nearest future, and more countries will follow, creating a unified digital identity solution in the EU or possibly in the whole world. And we at Ackee are very glad that we've been able to work on such an innovative and important project. This is a long-term goal that we have at Ackee, and looks like we've got a lot closer to achieving it with eDoklady. This is all from us. I would also like to thank our partners who worked together with us on eDoklady, and thank you for your attention.
Thanks, the speakers. It was really interesting talk. Now we have time for some questions. So let's see the Slido. First question is, since the app ties documents to the device, device migration is therefore not supported. Users may forget to regenerate the document. How is this case handled?
Yeah, it is tied to the device, and migration is not supported, which is correct because there are some actual exploits on Android which allow you to extract sensitive data if you allow migrations, so they're explicitly banned there. And if you forget to regenerate document, well, I believe you can delete the old device from the website, from the Czech government website, you can just delete the document from the old device, and for a new device, you will have to just create it there again, download it.
Okay. Why is eDoklady not supported yet on all the Czech offices?
I believe that's not the question to us, so not much to answer here.
Should be mandatory from 2025, so we really hope that it will work since 2025. But I believe that in current state, sometimes it works, sometimes it doesn't work, but it is based on the office itself.
But the big step is that the police is accepting it now, right?
Yes.
So you can go outside without ID.
Yes.
Okay. Do you know that the app doesn't work on Android with default browser other than Chrome?
Yeah, so we've developed only the module. We did not develop the application itself, so this is not for us to answer for this. We only did the core logic. On the diagram, I've shown the scheme. We did the module with logic, but UI is not ours.
Do you use a library for Bluetooth communication on Android, or everything is developed from scratch?
Yeah, we do use a library that simplifies the working with Bluetooth, but most of the things are implemented from scratch. Like, of course, we use the cryptographic libraries from the Java, which is the correct thing to do. You never want to re-implement those. But yeah, for sure, we use some helping libraries, but we always test them, again, using the test, and that's why we've got the high test coverage.
How did you test the Bluetooth functionality? Just unit tests or something more?
Yeah, it's tested through whatever can be tested through unit tests is tested through unit test, and whatever is not possible was just tested with some devices in like reality. But the Bluetooth is the very complicated thing. It doesn't work very well on Android, but we did everything we could to make it as reliable as possible.
Thank you. Any crashes with encrypted shared preferences data store on Android? Because we have these crashes in our app as well.
Well, we'll then need to investigate those. Like, I don't think I can answer.
Do you monitor
anything.
Crashlytics like Ackee? Do you monitor?
We are not developing the app itself. That's the thing. We are only providing the module. So we are a provider of the module within the application. The application itself is not ours, so we cannot handle the crashes. It's not up to us really.
But if the crash is in your code, they will forward the bug, right?
Well, if they do forward the bug, we'll investigate it. But
okay. Did you make your solution core open source so it can be reused by other countries?
Not at the moment, and again, it's not up to us to decide what to do with the code. I'm not sure if there is a plan for that, so you would have to ask someone else.
I saw EU reference implementation that is in Kotlin. Are they collaborating with you as well?
No, this was implemented just by us, so there were no collaboration with EU here.
Are some of your libraries open sourced?
Like at Ackee, I think some of them are, but nothing related to eDoklady, no.
Okay, so many questions. Keep them coming, we have time. Is the implementation available for other EU countries?
Well, it's closed source for now, so I think the answer is no, but maybe it will be in future. Again, not up to us.
Who verifies their verifier and how?
Yeah, so the verifier creates a certificate. So to be a verifier, you have to be verified. Because as I've mentioned, mdoc reader authentication, this makes sure that the verifier is allowed to do the check. And this is used by a certificate. So there is some trusted certificate at the government, let's say, and they issue certificates to the verifiers. So just a random person with their own certificate cannot do the checks.
Are there any plans for using mobile ID for digital signatures of documents?
Not something I can answer.
Sure. Do you expect any major further development as more governmental agencies start accepting the app?
I think there are some plans, but nothing specific I can talk about now.
Does the proximity flow work for offline verifier?
Yes, it does. The whole flow works, I believe, while verifier and mdoc are offline.
Why did you decide for React Native? Do you consider Compose multi-platform, and what are the reasons behind the decision?
Yeah, so it was not our decision. The application was developed by someone else. We were only developing the modules, and we got as a specification basically that we have the React Native app, and we need those modules developed with this kind of functionality, and that's what we did.
Regarding the screenshots from other countries, how come when the government is involved, the UI looks like it was designed in Microsoft Word?
Maybe it was, I'm not sure.
That's a great question. We would too like to know that. So.
I think we answered the open source one already, and the last question is, the verifier is another app generally available on the app stores?
I think it's within the same application. It's within one app, you can be a verifier and the reader.
Thank you. Thank you all for so many questions. Thanks the speakers for a great talk. Now you can rate this talk in Slido. There will be poll open where you can rate the talk. And speakers will go into Speakers Corner, which is a red stall in that foyer before this room. And you can continue your conversation with the speakers. We'll have 10-minute break now. And the next talk here will be Lilia Abdulina, QA of programming language. Thank you.
Thank you very much.
Thank you.